Alan Morrison, our first presenter, is a longtime advocate of data-centric thinking. He brings a wealth of knowledge across a multitude of various technology innovations and trends. And since he's moved on from PwC as a senior research fellow, he's shifted to become an independent advanced technology consultant. And I think that's a very appropriate title for you, Alan. So it's wonderful to have you back. So lead us off again this year.
Well, thanks, Steve. I appreciate the kind introduction, and hello, everybody. I'm going to talk about the big picture, and so that's what I'm used to doing for PwC. For a long time, I was in the emerging tech space. So I'm going to talk about digital transformation, and I'm going to talk about where we are and where we should be, and what's getting in the way. So it's a topic that's near and dear to the hearts of enterprises and the consultancies that try to serve them. I've been in and around this space for a long time now, and I've known Dave and some of the others at Semantic Arts for a number of years. And several years ago, Dave got together this group to sort of brainstorm how to flesh out a data-centric architecture. And we called it the Estes Park Group. And that group I help out with. It's once a month. It's virtual now. We've got a meetup every month where we turn over some rocks and find out what's underneath and talk about what it means and just sort of brainstorm together on things. So that's on the first Thursday of every month at 10:30 Mountain. And then I also help lead a personal knowledge graph working group that helps people get hands-on with simpler techniques to get started for their own research management or other productivity use cases, for example. And that one's twice a month on Fridays at 8 a.m. Pacific. So you all are welcome to either or both of those. And if you need to, if you want to sign up, just let me know or let James or one of the other Semantic Arts folks know. So I'm going to talk about, in terms of transformation, I'm going to talk about where we've been, where we're going, you know, where we are now, and what's getting in the way, like I mentioned, and then sort of make a distinction between real transformation and just sort of going through the motions. And then I'll talk about the real opportunity that knowledge graphs and data-centric architecture suggest. So along the way, I'll be talking about trends. I'm used to digging up and following trends as an analyst. So hoping to cover a lot of ground in the next 20 or so minutes. I might have to skip some slides. So where have we been? Well, where we've been is pretty much where we started with digital transformation in terms of the typical enterprise, let's say 80% of enterprises. And I'm just providing a quotation here from a couple of the execs at Manpower Group. That's a pretty typical platitude about transformation. And it says, contrary to popular belief, digital transformation is less about technology and more about people. You can pretty much buy any technology. And then they go on to talk about the talent, supply and demand, and HR potential and that sort of thing. And not to discount the platitude, but part of this is false. We're not really in a situation now where we can just passively buy stuff and just expect it to sort of start to work for us. And that certainly wasn't the case before, and it's even wasn't the case before, and it's certainly not now. So it's a time when you have to be proactive about what your problem is, what you're solving, and what technology you're using. And you have to be willing to really sort of build more and buy less, because if you just depend on buying, you're never going to get anywhere. And last thing you want to do, as Dave points out in Software Wasteland, is you don't want to add to the Tower of Babel all the complexity that enterprises have to deal with. So I do think the platitude is partly true, because you've got people who are the main resource for any organization, and you've got this tendency toward tribalism. So you have to overcome that tribalism, that inertia. And so there's a lot of organizational change management that has to happen to make these things effective. And I don't want to discount that. The consultants do some of that too. But you have to keep in mind that you don't want to uh, upset the apple cart and make people think that you're making things more chaotic for them, or that you're just dictating to them. So it's a balance you have to strike. So here's the Tower of Babel I was talking about. And you'll see it goes back to pre-1970, before the web. And so we've still got legacy systems that keep us in the past. But more importantly, we still have the mindset that goes with those legacy systems before the systems really got the compute, networking, and storage to really do knowledge graph kinds of things. So it really requires a change in mindset. And if you don't have that change in mindset, we're just going to have more and more application-centric sprawl. So that's why we advocate knowledge graphs as a way to get started. And it's a way to build a graph of facts that will support your other information in the architecture, and really flesh out the relationships between entities. And so you're helping to use unique identifiers, disambiguate, synthesize, and then abstract the data that's really core to your organization in terms of how to run it. And then you're providing this platform for large-scale integration and interoperation. So really what you're building is a small piece of a contextual web. You're building a piece of context that people can operate in. So where are we now in terms of where what's the current status? Well, right now I'd call the status that we're in data oligarchy. And most of the wealth is accruing to companies like these. And that's because they've taken advantage of the data circumstances and have been savvy enough to really capture huge market shares in their individual areas. And there's a lot of overlap in these areas. These companies are tackling more and more verticals. So, IDC used to talk about an innovation graph. And once you're in the innovation graph, like these folks are, you can skate across to other opportunities. And it's all digitized, but it's all sort of made sense of, so that you can start up a healthcare department and really try to make headway in just about every vertical. So this market graph, market capitalization graph, looks at the 10-year period and what happened to market capitalization, the amount of capital these companies have. And you can see that Apple is well above the $2 trillion mark. And Tesla, just basically went public 10 years ago and is already at the $1 trillion mark. So all of these companies pretty much dominate the tech landscape, as you're well aware. And they're just storing huge amounts of data. Google is apparently storing 10 exabytes total at this point. And if you think about what an exabyte is, 10 exabytes might be a stack of books, if it's represented in print, that reaches most of the way to the moon. And these folks have millions of servers. Amazon has a 1.4 million. Microsoft has above a million. Tesla is basically using the car as a data collection and analysis platform. There's 2.5 million cars on the road, and they're really pushing the self-driving. But it's just another platform to connect data with too. And here's what else is going on, which is all this buzz around so-called D-Web or Web3, the decentralized independent web. And most of it's centered around blockchains and cryptocurrency, which is confusing because that's not really what a web is about. But the notion here is that we would dispense with intermediaries and just use the platform to manage the transactions and do some verification and validation. But of course, what's really happened here is that intermediaries have moved in and staked out a lot of territory. And the venture capitalists, like the ones in India, are investing hundreds of millions of dollars in this. So we're again the tail trying to wag the dog with the knowledge graph part of this. And so in terms of Web3 and where interoperability might occur, there are startups who are offering the one-stop shop solution like Axelar. And I have no idea how they're doing what they say they can do, but I'm sure it's not standards-based. It's all proprietary to them. So where are we going? Well, eventually we're going to get to these interactive digital twins that are pervasive. And the thing is, it's probably going to take 20 to 25 years to get there. But it's good to have the vision in front of us because it expresses what we need in terms of an enterprise technology environment. We really need contextual computing to be able to generate and interact in terms of these digital twins that we're building. Now, you're probably familiar with digital twins in terms of gas turbines and prediction. So you can predict failures on the turbines if you've got a model of the turbine that fits pretty well, or you're familiar with visualization that helps sort of get your arms around the data. And some people are claiming you can take data from spreadsheets and turn it into clear, actionable context. I don't know that I would go that far, but that's what they hope to help with on the visualization side. But these interactive twins, basically, it's anything that can be represented as a person, place, thing, or idea, and they have to be interoperable. So to make them interoperable, we need to have, like I said, contextual computing, and that means the third phase of AI. We're in the second phase of AI that has to do with statistical machine learning and deep learning, which is really good at perceiving and learning, but it's not so good at reasoning. The older generation of AI that Semantic Web is a part of is really good at reasoning, not as good as at perceiving. So you've got to blend the two together to get to more holistic intelligence. And so you're building these contexts with the help of semantics and statistical methods together. So what's getting in the way? Pretending we're solving problems when we're not. There's a lot of money spent on just very superficial, shallow transformation. And so what I would say is that transformation, real transformation, requires transformative methods. You want to take the tactics that we've advocated over time, openness to new approaches, building a foundation a bit at a time, proving the value of the solution that you're building, infiltrating the organizational tribes that might be at first resistant. There's a lot of techniques here that really requires sort of a guerrilla team approach that's not hostile to really try to gain a foothold in organizations. And you just have to, people who have followed us for a while realize it takes a long time to make progress. And that's why we're thinking it's going to take 20 years to actually get these interactive digital twins at scale. And so I always think back to the oil and gas industry and where they started in the 1870s and 80s and where they are now. So you've got to build the refineries for the data. You've got to transport or virtualize and federate it. You've got to have pipelines for your data to move it from one stage to another through the life cycle, et cetera. So all of this infrastructure has to be put together, and we have to work with what is coming together and sort of adapt it to the knowledge graph style architecture. And the reason that we're still having trouble with this so many years later is that we're still selling the old as new, even though we've got the compute, networking, and storage to be able to do a lot more. And the Tower of Babel I talked about was really a siloing machine. So no wonder that 80% of companies figure they've got high or moderate degrees of data siloing. And no wonder 2/3 of them are unable to provide a single customer view. It just comes from the fact that the architecture hasn't changed. It's still like the HP minicomputer architecture in some ways. So the mentality of provincial IT is still prevalent today. You've got to have a different mentality to really share at scale and really interact at scale. And it just takes a collaborative approach that's organic rather than inorganic, and just subscribing to SaaS is not really helping. It's getting in the way. So how do we start real transformation? How do we kickstart it? Well, we start building a transformation that actually runs, and understanding the root problem is really key to this. I think Dave really drove home in Software Wasteland what the root of the problem is, and how inefficient we are and how we could do things better. Now, the data-centric revolution lays out step by step what a method to solve the problem would be. And so it's really essential to get that kind of grounding in the topic. So we try to give these books to folks who actually need them and just try to get them to read them, because it really changes your perspective and helps you get to that new mentality. And what's the real opportunity here? Like I said, it's connected, scaled out, and contextualized business intelligence that helps you run your business. And so old BI has always had the drunk under the lamppost looking for the money problem. The drunk says, look, I'm looking for my quarter, and the cop says, did you drop it here? And the drunk says, no, I dropped it 2 blocks down the street. So the cop says, why are you looking for it here? And the drunk answers, because the light is better here. So we're trying to put light in more places so there's less observational bias. That's a big deal. That's a huge deal. The other thing we're looking toward is purpose-specific intelligence. And I think there are some good examples that already exist and have for years. Parsa Mirhaji is going to be talking about Montefiore and Einstein, how they're improving hospital outcomes and efficiencies at the same time. We've got examples like Blue Brain Nexus, a whole global community of academics who are reverse engineering the brain with the help of an open source knowledge graph. We've got DiffBot, which has been up and running for years on the e-commerce side, crawling the whole web for business-specific intelligence. And we've got Strice.ai in the financial services space, bringing together 160,000 sources, they claim, for anti-money laundering and fraud detection. So that's an order of magnitude more sources than, or two orders of magnitude more sources than what others claimed in the traditional data as a service space. So there's a lot of potential here. And I think the killer app is really ultimately supply chains and working across enterprise boundaries so we can be much more efficient and coordinated on the supply chain front. So some form of degrees of decentralization, not full decentralization, will help with the data protection and the data sharing. We've had Graph Metrics at our Estes Park group presenting on how they're using a solid pod based application for smart document sharing. Origin Trail is also in the supply chain area, helping Swiss Railways with tracking and tracing. So there are some really good things going on, but not a lot of people know about them. And so last thing I'd like to say is that you're going to have to become data centric to really take advantage of this stuff. And that means keeping the whole data life cycle in mind. And you really have to be an intelligence agency, or at least part of your company has to be an intelligence agency. You've got to be systematic about collecting and generating the data, as well as all the other things we're talking about. So, Steve, I hope I haven't taken up too much time. I look forward to the rest of the conference, and I hope I've kicked off a really super event. So thanks a lot.
Yeah, that was terrific. Am I live yet, or do I have to do something?
We're seeing your picture. You
Okay.
want to click
Share
the arrow button to share?
Yep. Window. There we go. Action. Whoops. Can you see that?
Looks good, Dave.
Great. Thanks. Okay. Well, I'm very much looking forward to the rest of this presentation. There's a number of the presenters who I know, and I know about a lot of their journey, and there's several that I don't. It's just very, very exciting to see, so many people on the journey. And as Alan suggested, this is not an overnight success kind of thing. This is something you have to kind of dedicate yourself to. Anyway, I'm going to spend just a few minutes for some of you constructing a context. What is the destination? Where are we headed here? Put some parameters around that. So here we go. Let's start by getting specific about what are we talking about here with data centric. At its core, it's just the idea. Let's start with a data model, not start with automating a business function. That's classically where applications come from. Here's a business function. Let's automate it. And data is just the side effect and the exhaust of solving that function. We think fundamentally there's a different way to go about that. And the other difference is scope. Right now, the scope is the enterprise. And the reason we want to do that, if you choose a scope less than that, then you've created integration debt. You have things to do in the future. I think in the longer term future, when we start to solve supply chains, et cetera, that the industry or the marketplace may be the scope. But right now, just the enterprise is a pretty ambitious scope anyway. So let's drill down a little bit more. This is a bit of a word sandwich, but this is what I'm going with these days. If I want to get very specific and make sure that people understand the distinction between the target here and business as usual, or frankly, or any of the many other fads that seem to come along. So, and no firm yet is completely data centric, at least that I know of. There's some that are fairly far down that path, but so it's really an extent. How far have you gotten toward this goal? But you're data centric if the functionality that you have, the behavior or the UI and all that kind of stuff, is loosely bound to a single, simple, extensible, federatable, universal, shared, and directly implementable model. Don't worry, I'm going to unpack that. So when we start with single, how is that different than what's going on now? Right now, in a typical enterprise, there's one data model per application. So every time you build one, every time you buy one, there's a data model already in there with all its own terms and structure and everything else. And every time, as Alan was suggesting, every time you go put down your credit card and get another software as a service, you got yet another data model. Every one of them is arbitrarily different. They're all complex. Therefore, you have thousands or tens of thousands of data models, each of which is complex. What we're talking about here is having a core data model for your enterprise, one. Second thing we're saying is this ought to be simple. Right now, every application data model already has thousands of concepts. And if you have thousands of applications, just do the math. You've got millions of concepts. We work with some data profiling companies that tell us some of the largest enterprises are managing hundreds of millions of attributes. And no wonder people have all these data cataloging and all this kind of stuff. The sheer complexity that people are attempting to manage is mind-boggling. And efforts in the past to like enterprise data modeling, even data fabrics, haven't really tried to address simplifying this. They've just taken it as is. And we're suggesting what's at the core is less than 1,000 concepts for the entire enterprise. And I know that sounds kind of incredible, but after you do it a few times, you go, well, yeah, it really, businesses are complicated, but if you really understand what's going on, there's not that much going on in any given business. The third aspect of this is the idea of extensibility. In a traditional enterprise, there's just no concept even of extensibility. You build an enterprise application, you've got millions of lines of code that are tightly bound to this rigid relational structure, and somebody says, gee, I'd like to add a little bit from my department. No, just go build another system and move data around and have some APIs or something. But there is no such thing as extensibility for all practical purposes. We're talking about this idea that you have a core, but as you specialize it per domain, you're just extending it a little bit and saying, what is it that is, what can I share in common, but what is different? So if, for instance, in this little example, if we had inventory, as you might, if you're making anything in your core model, maybe your hand tools have a few extra attributes to say, well, yeah, I have to check them out to this labor, I need to get them back, and things that you wouldn't normally have in an inventory system. Maybe in a different part of the organization, you have fresh produce, and all of a sudden there's a use by date. But you don't have to build a whole nother system just because there's 2 or 3 new attributes, is the idea of extensibility. Federatability is the idea in a traditional architecture. For the last 30 years, we've been moving data all into one place as if co-location was the answer to our problems. And that's how a data warehouse works. That's half of how a data warehouse works. You take all the data from your silos, extract it, move it around, transform, load, boom, you got a data warehouse. Maybe you can query that data warehouse in a way that you cannot query your multiple silo systems. And frankly, that's what a data lake is as well. We just said, transformation was too hard. Let's just extract and load. But in this architecture, we say, no, the co-location isn't the important piece. Understanding and meaning and simplicity are the important pieces. And these little arrows sort of represent the idea that there are maps, and you can leave data where it is if you choose, or you can migrate it into the graph if for speed or convenience. You can literally change your mind anywhere along the way. But the idea being, if I just know those many hundred concepts, I can query and eventually get to any data anywhere in the enterprise. Next up is this idea of universality. In a traditional architecture, there's really no good way to deal with disparate data. And by disparate, I mean non-relational, non-JSON, let's say. But this architecture, and we're going to see some really cool examples of this in the next couple of days, because there's a common denominator here that says all data can be represented in a graph. I'll have a few words on that in a minute, but it's that reduction to a triple, to an individual edge node thing that allows you to say, in the upper right-hand corner of this picture, I can take structured relational database and turn that into triples. In the upper left-hand corner, I can also take semi-structured XML, HTML, whatever, turn that into triples. The lower left, that's meant to represent social media. It's a weird graphic, but social media is already in a graph. It's just a matter of conforming it to your ontology. And then finally, in the lower right, that's unstructured text. In the last several years, there have been some NLP engines that have gotten really good, not just at finding named entities in text, but to find the relationships between them. And then when you have that, and when you can conform it to your ontology, you've got triples from unstructured data you can combine with triples from structured data. And then, I mean, that's been the holy grail in data warehouse now for 20 years. And I don't think they've made much progress on that. Next idea up is sharing. In a traditional architecture, you share by copying and transforming, because in system A, they called social security number SSN, and in system B, they called it tax ID. Even the most trivial thing like that, you're constantly, shifting, restructuring, all that kind of stuff. With data centric, not only are we sharing the meaning, as I was sort of suggesting up to now, you can literally share the data itself. And we're so not used to this. We've had some clients where, let's say you convert all the employee data into triples and it's now available. You can just federate directly over that. No more transformation, ready to consume. Somebody starts a project, and the first thing they want to do is, well, let's just copy the data and transform it. No, you don't have to do that anymore. It's available for, it's pre-packaged, if you will. And then finally, this idea that it's directly implementable. When we talk to people about, an enterprise ontology, a high-level conceptual model with only hundreds of concepts, they immediately think, and as we did, I grew up with this stuff, oh, that must be the conceptual model. And then there's a bunch more work to turn that into a logical model, and a bunch more work to turn that into a physical model. We even used to write scripts to turn ontologies into logical models and then physical models and all this kind of stuff. Until one day we woke up and realized, wait a minute, it was person at the top, and person in the middle, and person at the bottom. And transformation did nearly nothing unless you're going back to relational. So the observation here is that, no, there's really just one model. The conceptual, logical, and physical are one and the same thing. It's and all expressed in triples. It's expressed in the same way that the data itself is. There's really a little bit of difference between data and metadata, but only conceptually, certainly not structurally. So yeah, that's our destination. The next question is, how do we get there? I'm going to have a bit more kind of strategically and organizationally at the end of tomorrow. But for now, I just want to bring up a couple of points that we think make this a lot easier. And I think, and it's partly to set up the next several presentations, because I think you're going to see a lot of these things, these themes show up over and over again. So there's kind of a three-legged stool here that we think sort of best practices. The three legs are semantics at the top there, graph databases at the lower right, and model-driven everything, the lower left, model-driven everything on the lower right. So I'm just going to hit each of these very briefly to kind of create some context for the rest of today and tomorrow. So what does a graph database give you? It gives you flexibility, and especially integration almost for free. And this is what gets rid of your data silos. I'm just gonna spend a very few minutes on the mechanism that allows this, and then you'll see a lot of demonstrations of this, I think. So at the core is this idea that there's a directed graph. That's why they call them graph databases. They're not graphics like bar charts. They're graphics like directed graphs, node, edge, node. So every factoid is reduced to this idea of a triple, and a triple just expresses one chunk of information. So in this case, on the right is how we might have had it in a relational database. You can imagine that the agent database has James Bond and the much lesser known Andy Renton over there on in the relational side. What the graph database is doing is reaching in. You can almost see it here. You can imagine every cell is a triple where the identity of the row is the subject, the meaning of the column is the predicate, and the value of the cell is the object. If you just imagine that, you can pretty much take that and run with it. There's some adjustments along the way, but that's a pretty good first order approximation. Now, the other thing that's going on here, and where the integration almost for free comes from, in the relational database, 007, that means James Bond, right? That's the ID for the identifier for James Bond. But hang on, not really. I mean, 007 only means James Bond if you're in that database, that table, that column. Even another table, as we'll see in a second here, another table in the same database might put 007 in the third column and say, well, that's who I assigned the weapon to. And so the column heading is not ID, it's assigned to. You go, wait a minute, assigned to? How does assigned to, how does that connect? Which is why in a traditional system, analysts are completely fascinated and make a career out of the metadata. Because you have to understand this metadata. Because you have to snap the tables together. You have to know all this kind of stuff. All that stuff is gone, and it's sort of hidden in this slide. I don't know if you notice there's a little colon in front of the 007 and all these things. That's PowerPoint shorthand for the fact that there is a namespace in front of that identifier, and the namespace belongs to somebody. In this case, let's imagine it belongs to Her Majesty's Secret Service. And they say, okay, when I'm identifying James Bond in the the real world, not real, but in the nearly real world, when I construct an identifier, it's going to be HTTP. It's going to look like a URL. It's going to be HTTP : Her Majesty's Service.uk /agents _ 007. And the significance of all that is that is an absolutely globally unique identifier, because Her Majesty's Secret Service owns that namespace and assigns things themselves. And therefore, any place that it appears, it means exactly the same thing. And here's the consequence of that. Anytime you find another triple in another table, or even in a document, you go parse a document, you figure out this is James Bond, do a little bit of entity resolution and attach that to Her Majesty's Secret Service /agent 007 and say, oh, that node was assigned to the Rolex. That's actually a separate triple, but the graph snaps them together. And I hope the take-home point here is getting clear. No human was involved in that. You didn't have to know any metadata to assemble this. So that's where the integration almost for free comes from. The almost part is you have to get you have to have a scheme for getting the identifiers and making sure you use the same identifier for the same thing. Once you do that, everything else is easy. And then it's flexible and extensible, because it's not a flat two-dimensional table structure. You just keep adding, oh, that Rolex watch has the Garrett. I can take somebody's head off with it. And we could say other things about the Garrett, or where he's located. You know, the thing, you've seen lots of these pictures, these graphs, they just get bigger and bigger. And that's the whole point. That's where the flexibility comes in. It further comes in that not every instance of a class, let's say 007 is an instance of the agent class, necessarily has to have the same set of properties. You know, that's an idea from relational and object oriented, where a class is a cookie cutter for instances. Here, no, it's a much more organic thing. As I learn more about individuals or subtypes of individuals, I can have more information. Now, here's a warning about knowledge graphs. Gartner has decided that the most hyped sector, AI, has it now as its most hyped technology. Knowledge graphs, we're right there at the top, you know, of that roller coaster that ends in the trough of disillusionment. And you might be cynical and think, oh God, I don't want to get on this ride at this point. But if you get behind it and figure out, you know, where does Gartner come up with this stuff, or what creates the trough of disillusionment? I guess it's a self-fulfilling prophecy. When something gets hyped like that, a whole bunch of people rush in. Oh my God, this is the thing to do now. AI and knowledge graphs could hardly get better. So a whole bunch of people rush in who literally don't know what they're doing, sell a bunch of projects. Most of them fail. And that is exactly what the trough of disillusionment is. When that washes out, you know, the stuff on the right, the plateau of productivity is, you know, if the technology works, which in this case it does, people will come out the other end. I mean, I feel sorry for the people in the trough of disillusionment, but that's just a reality of being in this industry. Second leg of the stool, semantic technology. You know, semantics is the study of meaning. And OWL, which stands for the Web Ontology Language. It's a little dyslexic, but you know, it sounded better than wool. It's just a standard way of formally expressing meaning. So if you build a model in OWL, it's called an ontology. It's just a name for this semantic-based kind of a model. And what we're finding is that really practicing this as it's meant to be practiced is where the simplification comes from. You know, in relational and object-oriented, it used to be the state of the art was go interview a bunch of subject matter experts and write down whatever they told you, and those are your classes and tables, and that's where this unnecessary variety comes from. But if instead you interview them and have some reference point and think very deeply about, you know, gee, what is the actual difference between an employee and a contractor, or whatever the thing you've got going there, you can, this is where you get the ability to construct these models that are just incrementally different where they need to be, but the same where they can be. The other thing that semantics buys for you is there are rules built in, and the system can infer a lot of additional information that you no longer need to supply. And then finally, the third leg of this stool is to attempt to model drive as much as you possibly can. You know, this whole model driven idea, we were deeply into it in the 90s, had a patent on it, which expired, of course. But the idea is if you stare really hard at an application and say, what is it doing? You can create a semantic model of an application, you know, not of the domain, but of an application, of what it means to be an application. An application has transactions and forms and constraints and rules and things like that. And if you then say, aha, if I populate the model of an application and then create an engine that will interpret that model, then all I have to do is change the model and the application changes its behavior. It's the kind of the holy grail here, and it does two or three things for you. The first thing it does is dramatically reduce the amount of code you have to have in an application system. You can go from millions of lines of code. You will usually need thousands or tens of thousands for certain bespoke applications, or maybe add on a little ML module or something. But really the bread and butter forms and tables and graphs and transactions and schema, all that need not be coded in application code. And the second thing, one of the reasons that application systems are so brittle is because the dependency between the code and the data model is hidden in the code. It's marbled throughout millions of lines of code. It's very hard to find. And therefore, people are worried, if I change this part of the data model, what am I going to break? Well, you don't know, because who knows where it touches it. Whereas, think about this for a second. If your system is mostly model driven, therefore, if the description of the application is in triples in the triple store, by its nature, it's connected to the model itself. So if a query refers to the class person, or if 20 queries refer to the class person, then those queries have been reduced to model. And if 30 forms refer to person, and if 10 transactions or 4 constraints or whatever, when you go into change person, you can just see immediately, oh, here's all the things that I'm going to affect if I change, or may affect if I change this. It totally changes the game. It's getting a boost now because a big deal out there in the world is low code, no code. It's popularizing citizen development, which at some level is a good idea. I think in some level it's going to be a bad idea, because now we're allowing people to create silos faster. So what we want to do is say, look, no, if you have a little bit of discipline, if you have a shared model, we can have model-driven development without, inadvertently creating more and more silos, which is literally what low code, no code is doing right now. And then finally, this conference, as Alan suggested, we met up in Rocky Mountain National Park in Estes Park many years ago, 5 years probably, because we recognized that in order to implement what we're talking about here, we're going to need to shift our thinking about architecture. And in particular, the big shift is, historically, there was a lot of things we relied on application programmers to put in application code to manage things like authorization and entity resolution and constraint management and validation and all, those kinds of things have historically been written in application code in the systems. So if we're going to drastically reduce that with model-driven everything, and if we're going to bring all those silos and their applications together, we have to solve some of those previous application problems at an architectural level. And so this diagram, we sometimes call it the placemat, was sort of the evolution of that. Every year we bring practitioners together to figure out, how far have we come on this? And I encourage everyone, as you see these presentations today and tomorrow, everyone who's solved one of these knowledge graph data-centric problems has had some way of addressing most of these issues in this diagram. This is just this isn't an architecture, it's just a way of talking about architectures. I'm going to hit all these points really briefly, and then I'm going to finish on time, so that'll be good. But just to give you an idea of the kinds of things that shift from the application domain to the architecture domain. And the other thing I guess I want to suggest, at this point in the evolution of the industry, I don't believe you can buy this as a product. You have to, I think Alan suggests, you have to buy parts of it. All of these are solved problems. It's just a matter of bringing them together to solve your architecture. So very briefly, we call this the grapefruit inside the onion, because the little thing in the middle sort of looks like a grapefruit. It's got a lot of layers, kind of like an onion. What's going on in the center is meant to represent, each one of those little wedges is meant to be another repository, a triple store, a bunch of data. Some of them on the right, that are in darker yellow, are meant to be curated, traditional enterprise data, payroll data, inventory data, all that kind of stuff that were traditionally closed world kind of stuff. The stuff on the left that's lighter in color is meant to represent data either that we harvested from somewhere out on the web, and you can't do you can't do the same kind of quality control that you do with your own curated data. Maybe the data isn't even in there. The white thing represents, maybe this is just a map to some data that exists elsewhere. Then surrounding that, you have a way of federating a query over those. There's a lot of standard ways to do that. Surrounding that, you have this shared model, the enterprise ontology that we talked about. Surrounding that, you really need to have security and access control and all those kinds of things, at a data centric level. You have to have a way of describing who can see what, because as you'll see, pretty soon, once you start collapsing all the data of a firm into one accessible point, people can start wandering into things they shouldn't be able to wander into. People find that, as they get into their journey. As we come out a little bit further in the blue there, we've got identity management. How do we know whether two vendors are the same vendor or not? It's classic, somewhere between master data management and entity resource identity. Then we've got integrity management, which is constraints and triggers. The circles start to get a little epicentric here, meaning most of the functionality on these next couple of layers applies to the curated data. You don't do a lot of constraints and integrity management for stuff that you're harvesting. Come out a little bit further, we start applying behaviors, the things you typically program, everything from geospatial to temporal things. Then start specializing individual subdomains and taxonomies. Coming out now to the green, I've lost track of where there it is. And then you have to just be able to get into this environment at all. So authentication. And then finally, the purple at the edge, we've got in the left side, there would be some bespoke user interfaces. But at the bottom, we've got an interface for people building models. And at the upper right, people consuming models. So anyhow, I just wanted to kind of introduce the lay of the land, the landscape. Very excited to hear all the rest of the presentations, including Parsa's. I've heard Parsa's presentation many, many times, but it's always great. So I'm turning it over to you now.